This is Gary. Although he doesn't look like much, he is my friend, and is also looking a bit worse for wear, which is why he's going to be getting a new home. But not just any home, I'm going to be using my engineering smarts to install a pump to give him all the water a growing plant needs. Although I can't drown him, I'll add a soil moisture sensor and an Arduino Nano. So first, I'm going to see how my pump works. It has a submersible area at the bottom for an intake, and a hole for a tube at the out. Seems easy enough. Just slap a tube and a connector on there. To power it, need maybe like 5 volts, although the ends are just straight up wires. I was hoping for a dew point pin thingies. What I'm supposed to do, just shovel a breadboard into it. For now, I'll just destroy some of the many wires I have for some end connectors. It's actually very annoying to re-crimp them and put them back on. I don't know what you actually should do for modules like this that are just wires. I'm sure there's an easier way. Anyway, let's see if the motor can turn on. Well, yes and no. It does work, but only if I power it with the Arduino 5V rail. I can't seem to use the Arduino controllable pins like the classic Blink program. I'm pretty sure those are also 5V. Let me check. And yeah, 5V. So what gives? Oh, I see. I don't think these pins give enough amp or watts. I don't know. But it looks like my pump is a high power device, which means I can't control it. Is it really all the way on or nothing? I'll have to think about it. For now, let me look at the moisture sensor. Oh, it's really easy. Just plug in the wire and... okay. Although the dew point connector doesn't fit in perfect alignment with the voltage, ground and out wires anywhere in my Arduino Nano. Okay, annoying, but for now let's just put in some wires and put it straight into the Arduino. Okay, it just gave me some numbers of the moisture. Perfect. I can even graph it and change it a bit when I put my hand on the end of it. Okay, so back to the pump. Doing a bit of research, I think a MOSFET seems to be my answer here. A MOSFET is simply a 3-pin device with a gate, drain and source. Simply, when we power the gate pin, electrons can flow through the device. In this case, from the source to the drain, connecting ground and turning on the pump, kind of like an electronic switch. It looks like if I hook it up to the power rail and a pin, I'll be able to control it. And turns out, yes, it does work. Okay, I have my circuit. For my code, I simply take the numbers from the moisture sensor, check to see if it be higher than the threshold for dry soil. I've set it as 460. This then turns on the pump for 10 seconds. I have it as 1 second for testing. Then wait every 30 minutes, or 3 seconds for testing for the next update from the sensor. Now, what I want is not only stretch my engineering muscles, but to deadlift them. So for the first time ever, I'm going to make my own custom PCB, and it's going to turn out great. Definitely not going to mess up the size of an important component, or just get confused how PCB way works 3 times until I realize KiaCad has its own plugin. Anyway, it's done now. I just have to wait a few days for it to ship. Okay, here is my PCB, and obviously straight away the size of the MOSFET holes is not right. I should have just taken like 5 seconds and look at the 3D model and realize I clearly have a wrong footprint. No matter, I believe I have a plan. I can just add some wire that fits in the hole and then solder the MOSFET onto the wire. It's jank, but it'll let me salvage the situation. Although a little bit tricky to do, it was great to get back into some soldering practice, plus even got a new soldering iron as my old last one kind of died. After that, I can solder in all my other components. Now the last step, to make the box to hold everything together. Here I use Fusion 360 to design a case and a lid to hold the Arduino board and the PCB inside, with the wires coming out of the holes. To attach it on the plant pot, I decided on a rectangular overhang, as I didn't really want to work with exact circles, and then when that broke after testing, I had to use the circles anyway. Okay, with that printed, and just barely fitting together even with a bit of sanding, I'm ready for integration hell. Past me clearly did not do me any favors for this part. Firstly, I had to resolder the pump back onto the board so it can slide through the hole. Repotting Gary was a treat, nothing wrong with that little cutie. The connector for the tube fell out, had to go get another one. Whoops, a bug in the code, fixed that, and yeah, pump does not turn off. Huh? Okay, so after ripping everything apart and debugging it, I can't control the pump, and through this exercise, my MOSFET leg broke off. So I got another one and tried to solder it in with some slightly longer wire, which was no less equally annoying. Add some electrical tape and it should just work with the Blink code. Okay, so on and then off and on again. Yes, I finally fixed it. Must have been a short circuit or something. And so that's it. I can plug the Arduino into the wall outlet and switch it on. Now giving Gary his new home that can water him whenever he is thirsty. Thanks for watching.